Hello everybody, I hope you can hear me, and if you don't, please let me know. My name is Ioana, as Antonio introduced me. I work at the Nuffield Department of Women's and Reproductive Health at the University of Oxford with Dr. Gabriel Davis-Jones, and it's an honour to be here presenting to all of you. I'll be talking about developing large-scale international datasets for fetal monitoring. So just to quickly outline what you can expect from me today, first of all, I'll be foregrounding the scene a little bit, talking about AI and data in maternal fetal health, what we see as its potential to make serious change and set standards, but also what's standing in the way currently of progress. Then I'll introduce the approach we've been taking in Oxford to data in order to use that as kind of a model of how we think data can solve these issues. I'll talk about collecting and processing the Oxford data, as well as our commitment to transparency and openness, and discuss a little bit about what we're aiming for, what we're keeping in mind during this process. I'll then talk about expanding worldwide, and then finally a little bit about where we see this work going in the future. So just to quickly set the scene, AI at this point maybe needs little introduction, but in the field of medicine in general, it has the potential to improve diagnostic accuracy and improve patient outcomes, but also to streamline operations and to relieve some of the pressure on healthcare professionals in order to allow everyone to do their best work. But there is an AI and data gap in women's and reproductive health in general, so this is a field that traditionally is underserved in these areas, which has the potential to reduce our possibility to do research in these fields. And this is despite obstetric care having particular challenges. For example, there's a large intraoperator variability in CTG monitoring. So one solution, good data. So AI is what is maybe informally known as garbage in, garbage out. To train AI, you need data. To train good AI, you need good data. And what I mean by good is detailed, large, high quality, and contextualized. And just to dig into a little bit about why we need these particular traits specifically, ultimately what we're looking for is to solve adverse outcomes and to try and avoid them happening. And while fortunately they're very rare, the impact when one does happen is potentially devastating. So we need oftentimes a complete picture of the pregnancy to understand where one came from and in order to predict it in the future, hence why we need all this detail. We need a good understanding of the different ways they can happen, hence a large amount of detail, because I mentioned they are fortunately very rare. We need high quality data in order to actually train a proper model that we can be sure is performing as expected. And finally, we need to be sure that models we train are contextualized, so we aren't trying to solve people's problems with tools that were trained on a completely different data set from somewhere completely different that may have nothing to do with them. And overarching all of this is the need to be transparent and open, because you can't just take our word for it that we've done all these things and we've done all of our best practices. We'd like to be able to be held accountable on these as well. So, OXMAT is the data set that we're working on in Oxford. It's short for Oxford Maternity, and it was developed in Oxford in 1991 by Professor Chris Redman, who Antonio has already briefly mentioned, and his team. And over the years, it's grown from midwives copying outcomes to match CTGs from paper notes, with the addition of all of these new sources in roughly chronological order, electronic patient record systems. So we can have a complete picture of the history of both mother and baby and of their demographics. Cord blood gases, ultrasounds, and neonatal ICU records have also been added in. And finally, we have Embrace, which is a national UK audit of maternal and neonatal deaths. So this is where we're trying to bring in that detail that I talked about, getting the complete picture of the pregnancy so that we can fully understand it. Where that gets us is a data set that contains over 211,000 CTGs from 250,000 pregnancies. About 250 clinical variables split up more or less as follows, also with many biomarkers interspersed among these various sources. Very large. And a few examples just to pull out of some adverse outcomes that we have present in this data set. So we're getting some representation of all of these adverse outcomes in the different forms that they can appear in, with a complete picture attached. So how did the data actually reach this stage? So we have several commitments to ensuring the data is of high quality. First of all, before the data even reaches the data set itself, it's coming from these various sources, it's undergoing a regular quality control review, ideally weekly, with a multidisciplinary team, so that we can check everything from our various different areas of expertise, both clinical and from a data perspective. We're doing them regularly so that we can ensure nothing is missed, and we're aiming for a comprehensive interrogation of the data quality and a complete understanding of what's happening clinically before the data gets to us. Then the first step is to standardize and merge the data. So we're having to ensure that data points are matching across the sources, that an ultrasound on baby A is not being matched to the neonatal outcome of baby B, for example, and to ensure that we're being universal in how we're applying formatting and cleaning steps, so there's no inconsistencies in there. Then more specific cleaning. So it's important to note here that we have no control over data entry, and standards change in time. For example, a binary variable may have been recorded in as yes or no by one midwife, y or n by another, and 0 or 1 by a third. So we have to ensure everything's represented exactly the same. Standards have changed in time. For example, in Oxford, the way that we've recorded the ethnicity of the mother has changed over the time that it's been recorded as a data point. And then another really key thing is to monitor and address outliers, but also to categorize them in different ways. For example, the outlier where we have recorded that there was a stillbirth, but the baby had an APGAR of 10 at 1 minute is an obvious point that must be removed. A baby that was recorded of having a birth weight of 4.5 grams, they probably didn't mean grams, so that can be corrected. And there are other outliers where the data may have been entered completely correctly, but maybe it's just not something we want to consider. For example, filtering by gestational age in the data for a certain kind of model. And then finally, for this slide, a review of the accuracy and the completeness of the data set. So in real data, you're always going to get missingness. Is the missingness being represented accurately, or did someone put in a big N when they just didn't know what it was? Should that really be a missing value? Is the missingness expected? Are we missing a woman's length of labour because she didn't labour, or she did labour and just nobody recorded it? And finally, are the values consistent within the data set? So do we have accuracy in the sense that the BMI is matching the weight and the height, for example? And this is where we're aiming to ensure high quality in the data. And then after that's all happened, there's more. So first of all, once the data has been processed and merged, it undergoes both manual and automated checks, because a human and a machine both miss things, so we've got to cover all our bases here. And those automated checks are built into the processing, so it hopefully isn't missing absolutely anything at all. Then it's important to hold any data that both comes from and is being used on real people to certain ethical standards. So we're aiming for an appropriate degree of anonymization and, of course, monitoring consent. Even though the data's been running for decades now, just making sure that we have everyone's consent for using the data in the way that we are. And then finally, our data management is being reviewed and approved on a rolling basis by information governance experts, and we're aiming to keep it updated and compliant with all this array of logos that you see here from various people whose standards that we're being held to. So that was kind of foregrounding a beginning of our commitment to transparency and accountability. And to that end, we've gone a little bit further, and this is a video which I really hope will play when I press the play button, of Oxmat Online, which is a data companion website that we've set up. So what we've aimed for this to be is a complete companion for the data for anyone wishing to use it for absolutely any reason. So what a user will find here is not only an overview of the website as a whole, the history of the data set, everything that's happened to it, but also every single variable, this is birth weight for example, has its own page which you can see detailed and summary definitions, a description of the details of the variable, the ranges of data that we have, how the data actually appears both in its cleaned and its processed form, there we go, the availability that we have for it in time, and then how we actually got to that clean stage, so a detailing of the data processing, both in a detailed and a simplified graphical form. So as I said, this is part of our goal of transparency and openness with the data and how it can be used. So first Oxford, then world domination, that's the plan. So we have collaborations set up with the Royal Women's Hospital in Melbourne, Australia, from which we have 155,000 CTGs with outcomes and 1,500 clinical variables, as well as a remote monitoring initiative, home monitoring CTGs in India, from which we have 400,000 CTGs with outcomes, roughly around 150 clinical variables. So every consideration that I talked about earlier, where we're merging data from sources that came from the same hospital, still applies, except now that we're also dealing with different healthcare systems and standard practice in these different countries, and even different hospitals or within those countries. So we have a few more different things that we just have to be aware of. Just some examples that have come up when we've been doing this work. In India, the CTGs are recorded at a different frequency than the ones in Australia and the UK, and Australian APGAR scores are recorded as 5 separate scores rather than the UK aggregate, which may sound kind of minor, but when you're doing the data wrangling, it's definitely something that sticks out, and so on. There's lots of examples. And this is all about contextualizing the data and ensuring that when we do train a model, we're serving those populations with data that's actually appropriate to them. Just some quick conclusions before I talk about the potential future of the work. So in order to have a meaningful impact on patients and on the standards in the field, we need good data. It's completely vital. And good is quite a specific set of standards as we see it, and must also be accompanied by a transparent, open approach to reporting. And then what's next for us? Well, so first of all, our eventual aim is to have an open access data set for future research. That research will involve building robust and accurate machine learning models, which my colleague Jalid will talk about later. And ultimately, the goal is to make a real meaningful impact and set standards in the field. And just a quick thank you. So this work wouldn't be possible without a whole host of people. I particularly want to highlight Gabriel for leading the team and the UKRI for funding the project.